Hello children, in this lecture we will start chapter 7th and its D part, study of compounds, and the compound is sulfuric acid. So the molecular formula of sulfuric acid is H2SO4 and it is a diprotic acid. Its basicity is 2. Sulfuric acid in dilute condition dissociates in the form of 2H plus SO4 2 minus. This is the dissociation reaction of sulfuric acid. So each molecule of sulfuric acid is producing 2H plus ions in aqueous condition. So basicity of this acid is 2. Then manufacture of sulfuric acid, contact process. So this process is in your syllabus, contact process of sulfuric acid. This is the diagram of contact process. So as you can see here that the labeling is given here and the related name of the chamber or part are given here with their function. Okay, so we will discuss one by one with the help of this diagram, and after that on the basis of the detail which is given here. So the A and B are part of this contact process apparatus is known as for production of SO2. So these two portions of the apparatus A and B are related with the production of SO2, and out of these two A is blower, which is used for passage of purified air or oxygen. Okay, then the second part B is sulfur or pyrite burner. This sulfur A, this is blower, and this is B part, sulfur or pyrite burner. So these burners are used for the production of sulfur dioxide by burning sulfur or iron pyrite. Okay, the next portion of this apparatus is Purification Unit, and this is the most important portion of the apparatus, contact process apparatus. And this purification unit is the unit where gaseous mixture of SO2 and O2 is purified. Gaseous mixture of SO2 and O2 is purified. So this purification unit is having following parts from C to H. And the part C is known as dusting tower. Part C, this is dusting tower, and this is used for removal of dust particles by downward blow of steam. Okay students, so as you can see here that when iron or sulfur is burnt here, okay, and the formation of SO2 is taking place. This SO2 is sent here, and here we purified that gaseous mixture with the help of steam. So this steam is blown from upwards towards down, and the earthen impurities which are present in the mixture of SO2 and O2 will be wetted by this steam, and they will be settled down in this portion of the apparatus. This portion is known as dusting tower. Okay, so this is used for the removal of dust particles from gaseous mixture. The next portion is D, and this is known as cooling pipes, and these pipes are used for the cooling the gases by passes through isolated pipes. So here this portion is used for the cooling of gaseous mixture which is coming out from the dust tower towards the next scrubbing tower. So this is a scrubbing tower. So between the scrubbing tower and the dust tower there are cooling pipes which are used for the cooling of gaseous mixture. Then this E portion of the apparatus, it is known as scrubbing tower, and this is for the further removal of impurities and dust particles by downward spray of water. So this scrubbing tower is used for the further removal of impurities which can be not removed by chance in this chamber. Okay, in this chamber, dusting tower. So the impurities which are left are further removed here in scrubbing tower with the help of downward spray of water. Then after this, next chamber, and this chamber is known as drying tower. So gaseous mixture from scrubbing tower is coming to this drying tower, and here this tower is used for the drying of the gaseous mixture. So for drying moist gases by downward spray of concentrated H2SO4. Okay, so here in the presence of concentrated H2SO4, the moist gaseous mixture which is coming from here to here will be dried up. Then after here, the mixture is sent to arsenic purifier. Arsenic purifier. This is arsenic purifier, and here we removed any impurity of arsenic if it is present in the gaseous mixture which is coming from the drying tower, from drying tower to arsenic purifier. Okay, so this arsenic purifier is used for removing arsenic oxide by passage over ferric hydroxide. Okay, so as you can see here, this arsenic purifier is having alternate racks, and these racks are having ferric hydroxide. So if any arsenic oxide will be present in coming gaseous mixture, that arsenic oxide will be absorbed by ferric hydroxide which is present here on these racks. Okay, then after this the gaseous mixture is passed through chamber H, and this chamber H is known as testing box. In this box we test if the gaseous mixture is totally purified or not. Okay, so for testing of the purity of the gases, we pass light through the darkened box. Okay, light through the darkened box, and if the path of light is not visible means the gaseous mixture is already purified. Okay, students. So these all are the part of purification unit. Purification unit from C to H. Okay. Now I am repeating all the steps once again. So as you can see here that these A and B two chambers belongs to production of SO2. A is blower, which is used to blow purified air or oxygen inside here to the pyrite burner. Now here in pyrite burner, sulfur or iron pyrite is burnt in the presence of oxygen to form SO2 gas. Okay, then from C to H, this is purification unit. So the gas SO2 and O2 means mixture of gas is coming from pyrite burner to this first chamber of the purification unit, which is known as dusting tower. And in this chamber, steam is blown from the upper side towards the downward, and in the presence of this steam, the earthen impurities which can be present with the coming mixture of gases will be wetted and they will settle down in the chamber. Okay, now after this heated mixture of gas will be passed through cooling pipes D. Here a gaseous mixture will be cooled down. Now this cooled mixture then passed to the next scrubbing tower, and in this tower water is sprayed from upper side towards lower side in the chamber, and in the presence of this water the impurities which can be present in incoming gaseous mixture will be washed away. After that, gaseous mixture is sent to next chamber of the purification unit, which is F, and this chamber is known as drying tower. Here the coming moist gaseous mixture is dried up. Then from here to arsenic purifier. In this chamber, racks are there in alternate position, and these racks are having ferric hydroxide. So if any arsenic oxide is present in gaseous mixture, then that will be absorbed here in ferric hydroxide. Okay, then purification of the gaseous mixture will be checked with the help of testing box, which is the last chamber of this purifying unit. So here purification of gaseous mixture will be checked if gaseous mixture is fully purified or not, or all the impurities are removed or not. And then from here gaseous mixture is sent to next chamber, which is known as catalytic, which is known as contact tower. And here in contact tower, catalytic oxidation of gaseous mixture is taking place. Okay, so gaseous mixture is having SO2 and O2, and this chamber, which is known as catalytic chamber, is having catalyst. Okay, so in this catalytic tower, the oxidation of SO2 to SO3 by passage of sulfur dioxide and oxygen through iron tower, this is iron tower, which is packed with vanadium pentaoxide catalyst, initially heated to 450 degrees Celsius. Okay, So this is the catalytic chamber where oxidation of SO2 will takes place with the help of oxygen in the presence of catalyst vanadium pentoxide. Okay, so in this chamber SO2 and O2 are coming from here, and vanadium pentoxide, which is heated in condition, is present already here as a catalyst, and in the presence of that vanadium pentoxide V2O5, SO2 will be oxidized with the help of oxygen in the form of SO3. Okay students, then after this SO3 will be sent to next chamber, which is absorption tower. And in this tower, absorption of SO3 is taking place in concentrated H2SO4. Okay, so SO3 which is formed here is coming from this catalytic chamber to absorption tower, and this SO3 will be get absorbed by concentrated H2SO4, which is sprayed from upper side of this absorption tower. Okay, so here after this, when we send this SO3, and that SO3 will be absorbed in concentrated H2SO4, which is sprayed from upper side of the tower, then oleum will form. Means H2SO4 plus SO3. So these together forming H2S2O7. Okay, this is the formula of oleum. So oleum will be formed here. Then this oleum will be taken out from outlet and it will be diluted. Okay, it will be diluted with the help of distilled water to form sulfuric acid of appropriate concentration. Okay students, so at last the chamber is K, which is known as dilution tank. Chamber K is dilution tank, and this chamber is used for the dilution of oleum by flow of requisite amount of soft water or distilled water. Okay students, so this is the contact process of sulfuric acid. Okay, so overall in contact process we are forming at last oleum, and this oleum is diluted in dilution tank to get sulfuric acid of appropriate concentration. Thing is manufacture of sulfuric acid contact process. So step 1 is chamber is sulfur or pyrite burner. So what conversion is taking place in this pyrite burner? Production of sulfur dioxide by burning sulfur or iron pyrite. Okay, so pyrite burners are used, sulfur or pyrite burners are used to convert sulfur or iron pyrite in the form of SO2 by burning these in the presence of air or oxygen. Okay students, so sulfur plus oxygen forming sulfur dioxide and iron pyrite with oxygen forming ferric oxide plus sulfur dioxide. Now step 2, the next chamber is contact tower, and in this tower catalytic oxidation of sulfur dioxide to sulfur trioxide. Contact tower, which is in which catalytic oxidation is taking place of SO2 to SO3 in the presence of V2O5. Okay, at 450 to 500 degrees Celsius and 1 to 2 atmosphere pressure. Okay students, then in this chamber catalyst which is used is vanadium pentoxide, V2O5 or platinum. Temperature is 450 to 500 degrees Celsius. Pressure is 1 to 2 atmosphere. Conversion ratio is 98% of sulfur dioxide converted to sulfur trioxide. Means a very good yield of sulfur trioxide is obtained. Okay students. Then chamber third is absorption tower, and in this chamber absorption of sulfur trioxide in 98% sulfuric acid to give oleum. So formation of oleum is here, and the formula of oleum is H2S2O7, which is formed due to the absorption of SO3 in 98% H2SO4 in absorption tower. Then this H2S2O7 oleum is diluted in dilution tank to obtain sulfuric acid of appropriate concentration or of required concentration. So dilution of oleum with calculated amount of soft water to give sulfuric acid of desired concentration. Okay, so this is the overall summary of contact process. Okay, chemical equation summary of contact process.